Hello students, today we'll discuss IB Mathematics SL Paper 1, May 2019, time zone 2. In this paper you cannot use calculator. My name is Nariman Malim. I'm located in Baku, and here you can see my mobile and email. Main sources to prepare for exam is textbook of 2012. And here you can see that you should have formula booklet with formulas. Why? Because first of all you have formulas there, and this booklet will be available for you during exams. This is the cover page. Section A, question 1. The following table shows the probability distribution of a discrete random variable x. So value 0, 3, 13, value 1, 1, 13, value 2, 4, 13, and value 3, k variable. Find the value of k. A. Total probability should be always 1, so we add all probabilities and it should be equal to 1. After adding fraction, we get 8 13. 1 minus 8 13 give us 5 13. So this is the first answer. Find expected value of x. From booklet, section 5.7, expected value of discrete random variable x is equal to the sum of value by probability. Sum. So we add product of probability value times probability, value times probability, value times probability, value times probability, and we get 24 13. Done. Question 2. Consider the vectors a and b. Find the p for which a and b are parallel. A. So there, if they are parallel, then b will be equal to k multiplied as a multiplied by some constant k. And each component, for example, 0 equals k0, 6 equals 3k, 18 equals pk. So because 6 equals 3k, we can find k, so k is 2, and 18 should be equal to 2p, so p equals 9. Perpendicular. For this, to show that the vectors are perpendicular, we are using section 4.2. Angle between two vectors is found from cosine. Cosine will be equal to scalar product divided by their magnitude. Magnitude of the vector is given by this expression, scalar product is given by this expression. But if they are perpendicular, cosine equals 0, so we don't need magnitudes, we need only scalar product, and it should be equal to 0. So we find scalar product, make it equal to, so it is 18 plus 18p, make it equal 0, and we find p equals minus 1. Done. Question 3. Consider the function a. For the function for graph of a, write down the equation of vertical asymptote. So vertical asymptote is when function is infinite. It is infinite when x minus 2 equals 0, so x equals 2. The equation of horizontal asymptote. So we rewrite this formula in this new form by dividing numerator and denominator by x. Then when x tends to infinity, our function tends to 3. So y equals 3 is horizontal asymptote. Let g equals x squared plus 4. X is real number. Find fg1. So first g acts on 1, and then the result is taken by f. So first we find g of 1, substitute values 1 squared plus 4 equals 5. This 5 is taken by function 5. So function f of 5 equals, we substitute values into this formula, and we get 16, 3. Done. Question 4. The following diagram shows part of a graph f with x-intercept and y-intercept. So y-intercept is 8, x-intercept is 5. Find the y-intercept of graph fx plus 3. So y-intercept means x equals 0. So we need f of 0 plus 3. F of 0 is 8, so we getting 11. The same for this function. So x equals 0, f of 0 equals 8. So found. Find the x-intercept of graph f of 2x. X-intercept means y equals 0, so we need to find when f of 2x equals 0. But from graph we know that f of 5 equals 0, so it means that 2x equals 5. X equals 2.5. Describe this transformation x plus 1. So because we add some constant to x, we should do opposite action to the graph. So translation or shift of graph to the left by 1 unit. These words are important. Either translation or shift are terms, so you are expected to use these terms. Question 5. Consider the function. Find the value of k for which fx has 2 equal roots. Quadratic equation. We have quadratic equation. Discriminant is given by this formula, and it should be 0 for 2 equal solutions. Hence, here we have a equals 1 minus k, a equals minus 1 minus k, b equals 1, and c equals k. Substituting this into discriminant and making it equal to 0, we get equation for k. This equation can be solved either using formula for roots or understanding that we have square of 2k minus 1, and when it equals to 0, k equals 1 over 2. Question 6. Solve. So we use from section 1 to change of base. So we are going to change 16 base to 4. For this we are putting here 4, but divide by logarithm of 4 over 16. 4 over 16 is 1 over 2. Rewriting, and then we use law of logarithm, so this 2 goes out. From 2 times becomes 2 minus x squared, and then we make equal the bases. With bases, open brackets, and then we get 2 solutions, minus 3 and plus 3. But because bases should be positive, 2 minus x should be positive, so x should be less than 2. So we choose minus 3 and exclude plus 3. Question 7. Consider the graph of function fx equals to sine x, x from 0 to 2 pi. The graph of the f intersects the line y minus 1 exactly twice at point A and point B. This is shown in the diagram. Yes, point A and point B. Find the x coordinates of A and B. So 2 sine x equals minus 1, sine x equals minus half. So minus half is 2 solutions. One is, so this is for positive half, we have pi over 6. One solution will be pi plus pi over 6. Another solution is 2 pi minus pi over 6. So we have 2 solutions, 7, 6 and 11, 6 of pi. Find the greatest value of p such that the graph of g, so we consider the graph of g equals 2 sine px. Find the greatest value of p such that the graph of G does not intersect the line Y. So when we multiply x by p, we are stretching our graph, and here they want us to find the value of p such that our new graph doesn't intersect y equals -1 in this region. So I have drawn extreme value when it intersects at the boundary of this region. Let us see what we'll have. So at x equals 2 pi, our function intersects -1 line, and we getting solution sine 2 pi p equals -half, and we choose the first solution because, as you see here, point A turns into point A prime, and rewriting we are getting p equals 7, 12. Now we come to section B. Section B. I have divided window into two panels. Upper panel we have question, lower panel we have solution. Question 8. A group of 10 girls recorded the number of hours they spent watching television during a particular week. The results are summarized in the box and whisker plot below. So this box and whisker plot you should know. So this is minimum value, maximum value, first quartile, third quartile, and mean value 19. The range of the data is 16. Find the value of A. So question A, range equals maximum minus minimum. Range equals 16, maximum equals A, and minimum equals 8. So we get A equals 24. Find the value of interquartile range. Interquartile range, by definition, is third quarter minus quartile minus first quartile. 20 minus 15 from the diagram equals 5. The group of girls watched a total of 180 hours of television. Find the mean number of hours that the girls in the group spent watching television this week. Mean equals total by number. So total is 180. Number is 10 girls. We are getting 18 hours. A group of 20 boys also recorded the number of hours they spent watching television that same week. Their results are summarized in the table below. D.I. Find the total number of hours the group of boys spent watching television that week. So now we are using the same formula, mean equals total by number, rewritten for total. Total will be average by number. Average is 21, and number is 20 boys. So total will be 420 hours. Find the mean number of total hours that all 30 girls and boys spent watching television that week. So mean will be total by number. Total, we can number write straight away because they tell us 30, although we know it is 10 and 20, and hours 180 and 420. Total will be 600, so mean will be 20 hours. The following week, the group of boys had exams. During these exams, the boys spent half as much time watching television compared to the previous period. E. For this exam, find the mean number of hours and variance in the number of hours. Page 281 of textbook tell us what will happen if we multiply, for example, original data by some constant. If you multiply all the numbers in the list by a constant value, both the arithmetic mean and the standard deviation are multiplied by k. Here, all data are multiplied by 1 over 2, or divided by 2 if you want. This is why average will be divided by 2, and standard deviation also will be divided by 2. But they ask for variance. Variance is square of standard deviation, so new standard deviation will be 1 over 2 of previous, multiplied by 3, so it is 3. Actually, sigma is 3. If we look to the value, sigma is 3, so 3 goes here, 9 over 4. Next question is 9. Let theta be an obtuse angle such that sine theta equals 3 over 5. Find the value of tangent. So, obtuse angle, angle between 90 and 180. So, from booklet section 3.2, we have trigonometric identity, tangent equals sine by cosine. From section 3.3 we have Pythagorean identity, sine squared plus cosine squared equals 1. Rewriting this for cosine, and we can find that cosine is either plus or minus 4 over 5. Then returning to tangent and using sine over cosine, we are getting, we should divide 3 over 5 by plus minus 4 over 5, we get plus minus 3 over 4. So we should decide, is it plus or minus? This is the unit circle. All students take calculus. In the first section, all trigonometric trig functions are positive. In S, only sine. In T, only tangent. In C, only cosine. So because we have obtuse angle, tangent should be negative. This is why we choose negative answer, and we get minus 3, 4. So we found value of tangent theta. B. Line L passes through the origin and has a gradient of tangent theta. Find the equation of L. So general form is y equals mx plus c. M is gradient, so it is tangent theta. Constant c equals 0 because when x equals 0, y equals 0, so c equals, because it passes through origin. So we are getting y equals tangent theta x. Tangent theta we found, minus 3 over 4. So this is the result, y equals minus 3 over 4. Let f be this function. C, find the derivative of f. So, to find derivative of f, we should use, from section 3.6.3, product rule. And we have product ex and sine. So, we have first with derivative of ex multiplied by sine plus ex derivative of sine, which is cosine, and then minus derivative of 3/4 x, 3/4. The following diagram shows a graph. Let's look to this graph. This back is bigger. Right. The following diagram shows a graph of f for x from 0 to 3. Line M is a tangent to the graph. Okay, so line M passes through P and is tangent. Given that M is parallel to L, find the coordinate of P. So first derivative equals gradient of the tangent line. Gradient of parallels are equal. It means that our tangent line has gradient equal to gradient of L equals minus 3 over 4. And so it means that first derivative equals gradient. So first derivative expression equals gradient. First derivative expression equals the gradient. We can rewrite, so ax cannot be equal to 0. It means that sine plus cosine equals 0, tangent equals minus 1, and tangent equals minus 1 for angle tangent equals 1 for 45 degrees, and tangent equals minus 1 is for 135. So this is a bit, yeah. So negative tangent equals minus 1. Right. So we have pi minus pi over 4, or we can change 135 into radians. So this answer should be in radians. I don't know why, but answer they want in radians. Question 10. So we have function, we should have first derivative of this function. So we are using section 6.2 chain rule. So first we will find derivative of this exponent, and then what is under the exponent. So derivative of exponent is exponent of power, exponent here, exponent minus 1, and here derivative of power of what is on in this bracket will be 3x squared plus 1. So we have answer. This is the answer. This answer will be used in the next step. Hence find this integral. So we will have integration by substitution. Let us do the following. Let us call our function y t, then dt by dx will be our derivative, and rewriting for dt we are getting this expression. Now if you want to find this integral, you actually should find, so you have all this expression to integrate, and you're getting 2/3 over dt to integrate, so you have 2/3 over t, and you put the value of t. So this question is done. Consider the function f and g for x more than 0. The graph f and g are shown in the sketching graph. The shaded, just a moment, okay. The shaded region R enclosed by graph f and g. So g and f. So if we find area under f minus area under g, so write an expression for the area of R. So area under section 6.2, area under a curve between x equals a and b is equal by this given by this integral. So in this case we have from 0 to 1 g minus f integral. Hence find the exact area of R. So we are writing expression, and then we realize that This integral we already found. It is 2/3 of this function. You see, we found this integral, and we should find from 0 to 1. So it is value of this function at 1 minus value at 0. So value at 1 is this expression, value at 0 is 0, so we're getting this exact area of R. Here our paper is over. Thank you for your attention.